All right, thank you very much for joining me for this particular module in exploring the Physics Educational Technology AI Balancing Tool Act. My name is A.Kaburi, and we shall be diving into this module together. So, by way of introduction, this particular exploration of this particular tool, AI tool for teaching and learning of physics is going to be in two parts. First part, we are going to look at the Physics Education Technology Balancing Act simulation in practical terms, in terms of manipulating it with hands-on. And then we shall be looking at the key technological features as well as instructional benefits and the hands-on demonstration, like I said. And then the application in professional practice. And the part B, we shall be looking at adaptive and personalized learning, their connectivity in terms of activity and how they work. And then we shall look at the summary of key findings, also some differences between this adaptive and personalized learning, and we shall be ending this particular video on that. So, interactive, which we say to talk about the Physics Educational Technology Balancing Act. It's an interactive online simulation tool that is used for exploring balance, torque, proportional reasoning, and equilibrium, rotational equilibrium or moments. And those of us who are physics background or who have a bit of science knows that how this balancing or moment works in terms of theory and how we are taught in the physical classroom. But this is an online or the AI platform that gives you the opportunity to do it virtually and also to maximize your conceptual understanding. So students are able to position objects at different different masses, on an online learning environment on a beam to observe its effect, whether it's at the same side or is balanced or not. And like I mentioned earlier, if you are used to this balancing act in terms of movement, we know that clockwise movement is supposed to be equal to anti-clockwise movement for it to have a balanced beam. So this platform gives you the opportunity to manipulate and test this particular this hypothesis to come out with a reasonable understanding. So the key technological features of this platform or this AI platform is that you are able to drag and drop on the interface or on the platform with different objects of different sizes or weights or mass, and it gives you real-time feedback as well. Using the arrows when it's green, it shows that it's balanced. When it's white, it tells that it's still not balanced. And there's also an inbuilt ruler for measuring the distances, the dynamics of the mass selection, and it gives you that a scenario that gives you the opportunity for you to do your testing concepts. And its instructional benefits is that it gives you the opportunity to visualize abstract physics concepts, like I mentioned earlier on. We all know how physics can be abstract and can be difficult, especially when it comes to balancing and these talk principles. So it gives you the opportunity for you to visualize it and make it hands-on for students to be able to maximize their conceptual understanding. It also fosters inquiry-based learning as students experiment and receive immediate feedback on this particular simulation platform. And it gives them the opportunity to predict, test, and revise their scientific reasoning and to have an interactive way of learning these particular principles. So let's quickly look at this, how this platform works. Let's come here. So here is how the platform or the platform looks like. So if you want to be able to do your simulations, you have to toggle this on so that you can take these things for off. And this is what I was talking about. The forces, it's able to, if you click this particular check-ins, you're able to see the level that see the green arrow showing. And you can also have a ruler down there to give you the kind of measurement. If you click none, then you don't have it. So let's try to balance this 5 kg. So you see, if you put 5 kg here. You see that the arrows changes. And let's put another 5 kg here. You see that because the arrows are not at the distance from here to here is not the same as from here to here. You are not able to have a balanced beam. So these things are still white. Now let's move on to let's bring in the ruler so that we can see. So we see that from this side, the gas cylinder, which is 5 kg, was on 125, 1.25, and here is on 2. So let's try to bring this here to 125 and let's see something. So 125, let's see what happens. Whoa, there you go. So we see that here it turns green, indicating that this particular uh, simulation is balanced. And now we can see that the distance from here to here is 125. The distance from here to here is 125. Let's try to do it at another position and see how it works. Now let's bring this to 175 and then 175. It balances. Great. There you go. So you see that we have our green model again. And if you check the measurement 175, 175. Let's see if we check this max and see what happens. So we see that the marks are also same. So if we are using the marks, we have mark 7 here, mark 7 here. So with the same kind of mass, 5 kg, 5 kg, always at different size or opposite sides of the beam, you should have a balanced system, and it turns green when it's balanced. So if we try to shift it a bit, if you bring this here, you see what happens. We destabilize the system and it's not balanced. But let's bring this to 6.2 and let's see what happens. There you go. So you see that we have the green thing or the green color arrow indicating that the system is balanced. And now I want us to try to see another thing. So if we use the rule, so the rules and the max can all be, if you use a rule, you see that they are all at 1.5, 1.5 each. So it should be, so if you, like I mentioned in in the introductory part of the video, if you multiply 5 by 1.5, you get it's the same value as multiplying 5 here by 1.5. So we say sum of the clockwise moment, which is this 5 times this 5 times this 1.5 is equal to this 5 times this 5. So sum of the clockwise moment should be equal to the sum of the anti-clockwise moment. And that is how this particular simulation works. I hope you are enjoying it. Now let's try to see if we can balance this with the trash can. So let's bring this here on one. Now, so if you add this to this, we have 10 kg. Now we have 10 kg of trash here. Let's try to see how it's going to work. Let's put it here. Whoa, so it's not balanced. So here we put one here. Now let's try to bring this a little bit here. It's still not balanced. Now let's try to bring this here a bit and this here a bit. It's still not balanced. Now let's bring this here. I'll bring this a little back and this here. Wow. Oh la la. Yeah. So you see, so if we want to balance this, you see that we also have 10 kg here, but you have to put them at different positions in such a way that the clockwise moment should be equal to the anti-clockwise moment. So if you multiply 10 by 1.75, you should be able to get a same value as 5 times 2 plus 5 times 1.5. So the sum of the clockwise movement should be equal to the sum of the anti-clockwise movement. And we are able to get one moment by multiplying the mass by the distance. Mass by the distance. And we can also use the mass to check that. You see that here it's on 7, and here it's on 6, and here it's on 8, and here it's on 6, and we got it balanced. So I think this really helps you a lot. And of course, if you want to restart the whole simulation again, you just click this button and then you restart the whole process again. I hope you enjoyed this simulation and you can try to practice the rest back home. Now let's go back to our section B of our presentation. All right. All right. So looking at that particular simulation, I hope you enjoyed it. Now let's move on. So we can be implementing this in our profession as a teacher. This can also be inculcated, used to do formative assessment. We saw how we're able to do it. So we can give students the opportunity to manipulate it and come out with their own capturings of their screen and give you explanations of how they were able to balance each of the masses. And you can also use this to help you draw a lesson plan or in doing your preparation of your lesson, integrate it into your lesson plans. And also we can use this to plan activity like we did. We can use this in the classroom to help us improve upon our classroom or our lesson activities to make them effective and improve conceptual understanding. Part B is the adaptive versus personalized learning. And adaptive learning is a system of learning that automatically adjusts content or pathways based on the learner's data and performance. And we can also talk about the personalized learning, which is a kind of learning that people learning experiences are tailored towards individual preferences and interests. Learners may try to may help this shape their path through this, or it may help learners to shape their path. There are key differences is that adaptive learning uses real-time data analysis for dynamic content adjustment, and personalized learning is always selected based on selected goals or pace or the resource available to the learner himself. And adaptive learning is tech-driven and is often done through algorithms. And of course, personalized learning is centered with it's a learner-centered with the help or the support of a mentor or a teacher. The content of adaptive learning changes based on performance, but that of personalized learning content can be done or built in pathways that will help to improve the learner's interest or based on the learner's interest. Both of these aim to optimize the educational experience of individuals. Adaptive tools can be used to support personalized learning as well. So they help or complement each other based on recommendations. And in practice, most digital learning platforms integrate both of these approaches together to help improving the conceptual understanding of learners. We have seen the example of in our physics educational technology simulation that we did a couple of minutes ago about how we can demonstrate this adaptive learning when students get their instant feedback by trying to balance the different masses and with the trash can and all that. They get their feedback, encounter challenges, try to make adjustment with their decision making and come up with a solution. It supports them in terms of personalized learning as students investigate their own questions, select the difficulty, and explain their findings in their own way. Like I said, in terms of the formative assessment using the physics educational technology platform. It also encourages autonomy, and students are able to, or learners are able to become autonomous and make it a model for with blended approaches, support different kinds of learners with different learning strategies. So thank you very much for joining me. I know this video may be long because of our simulation hands-on activities that we practice, but I hope you learned a lot from it. And if you have any questions, you enjoy doing the simulations, you can let me know and join the physics educational technology platform and manipulate some of these things or use them in your own personalized classroom to improve conceptual understanding. Until then, see you again and thank you for joining me. Cheers.